Hello, Chemistry 11. This is Mr. Chan, and this is just a demo to show you some of the characteristics of predicting products when we're predicting the types of reactions. Now, recall when you're predicting products, what you need to do for single replacement reactions is you need to check the activity series. Now, the activity series kind of predicts whether or not a reaction will occur or not, and it depends upon where the free element is in regards to whether it's being replaced or not. So I have two samples here. In here, I have some copper nail, some copper. And in this case, I have some magnesium. Now I'm going to add hydrochloric acid to molarity, and this would be the classic single replacement reaction. Now, if I were to put it in here, you will notice with the magnesium, it reacts quite vigorously. You hear some bubbling, okay? So you know in this particular case that a single replacement reaction is occurring. Okay, what you're producing is you're producing hydrogen gas. This is why we have the bubbles, and you have magnesium chloride left over. Now, if we look at copper, notice for the copper, there is no reaction. Nothing is going on. The copper is not getting reacted. And the reason being is it's dependent upon where copper is relative to hydrogen on the activity series. So if you check the location of copper, you will notice that copper is below the hydrogen in the activity series. And as a result, it is not able to replace it to form hydrogen gas and copper chloride. In this case, why is magnesium reacting and now the reaction is over? Is because the magnesium is higher up than hydrogen. It is able to displace or react with the chlorine and release the hydrogen gas. Now, another example would be like here where we have an iron nail and we have, in this case, copper 2 chloride. Okay, now notice the copper 2 chloride is blue. So another way to recognize whether or not a reaction occurs is if I put this in here, okay, what we're going to do is we're going to let it sit for a few minutes. Okay, and I'm going to go on to another demo, and then when we come back, I will show you the difference. Now, the other thing that we talked about in a predicting products is a double replacement reaction. So double replacement reactions, what you need to do is you need to check the solubility table. So for example, let's say we have calcium chloride and we have sodium carbonate. Now, these are two compounds, and as a result, they're in solutions, and so the ions undergo a double replacement reaction. Now, notice that they are both clear. So if I were to put one of them into one test tube, okay, and if I were to put a second one in another test tube, and if I were to mix the two together, what you will notice is you have, well, it's not very good here, you have a white precipitate. So by looking at the solubility table, you can predict what the precipitate is from the two reactions. In this case, the precipitate would be calcium carbonate using the solubility table. Okay. Now, going back to the reaction here, I don't know if you can see this, but you notice that you formed little clumps. So what's happening here is in the bottom, what we have is we're forming copper solid. And what's happening is the copper ions are now being replaced by iron, and the copper ions are now forming copper solid. So if you were to look at the color of the original solution, in this case, it's nice and blue, compared to this one here, you will notice that it's a little bit more pale compared to what you had originally. And the reason why it's becoming more pale is because the copper ions, which account for the blue color, is actually being drawn out to form copper solid. So what you have is you have less ion in solution, so therefore you have less of a color. So these are just some reactions that, demos that just sort of help reinforce the idea of predicting products and types of reactions. And again, for single replacement reactions, like what we had here with the hydrochloric acid and the magnesium and copper, the copper chloride with iron, what you need to do is you need to check the activity series. When you have double replacement reactions, like in this case, calcium chloride with sodium carbonate, what you need to do is you need to check the solubility table to see what precipitate forms. All right, folks, thank you very much. Have a good day. Bye-bye.